Welcome back to another video by Overscoli. Today we are going to look at a question from the chapter of force and motion in your Form 4 Physics syllabus. Here there is a ball which is dropped down from a height of Q. The ball hits the ground and then bounces back to a height of R. And we need to sketch a velocity time graph for the motion of the ball. Since it's a sketch, we just need to use notations like V1, V2, T1 and T2. We do not need to indicate accurate velocity or time in the graph. Now in physics, it always helps us to visualize the question first, to understand what is happening. So here, before the ball is dropped, that's at point A. When we are holding the ball is stationary and hence it will have a velocity of 0 meter per second at A. When the ball is released, it will drop down with increasing velocity and reach point B just before it touches the ground. The time taken for it to travel from A to B is indicated by T1. We can assume T1 as any number. And the velocity just before it hits the ground is V1. Again, V1 can be any number, 20 meter per second perhaps. And then it hits the ground. When it hits the ground, it will lose some energy due to friction, loss of sound energy and etc. After that, the ball will bounce back. That's point C. It will bounce back with a velocity of V2. And please notice that V2 will be smaller than V1 because some of the energy is lost at B. So the ball starts with a velocity of V2 and it will go up. The velocity will gradually decrease and it will come to a point where the ball cannot go upwards anymore. That's point D. So at point D, the ball will reach a velocity of 0 meter per second. And the time taken to travel from C to D is T2. And logically, T2 must be shorter than T1 because the displacement is considerably shorter than the displacement from A to B. So this is the story that we need to translate into our velocity time graph. Now to sketch a velocity time graph, we need to perform two steps. First is to plot the points of interest, in our case A, B, C and D. And the second step is to join those plots using lines. So let's start with the first step, plotting of points. How do we plot the points? To know that, we need to go back to our additional mathematics knowledge. I'm sure all of you are familiar with your functions and you would have seen this equation, fx equals to y. The x here refers to the values in your x-axis and the y here refers to the value in your y-axis. So in simple English, this equation will read as, when my x is certain value, what will be my y value? For an example, when my x is 1, what will be my y? When my x is 10, what will be my y? So this equation can be adapted for different situations. Like in our situation, the equation will look like this. Ft equals to V. So our x-axis is now t, time, and our y-axis is now v, velocity. So our question will be like, at time 0, what will be my velocity? At time 10, what will be my velocity? So we will ask this question again and again to plot all the 4 points. Let's start with point A. Point A happens at time 0 in the beginning. So at time 0, what is my velocity? So we have already indicated that it is 0 meter per seconds. So point A will be plotted at 0, 0. Here comes point A. Now the next point is B, and it happens after t1 seconds. So just mark t1 after a certain spacing, and at t1 the velocity is v1. Now you need to decide whether it's positive v1 or negative v1. It's downward direction, and downward direction is negative. So you need to mark v1 in the lower quadrant, negative axis, negative v1. So the intersection of negative v1 and t1 is where your point B comes. Next will be point C. The bouncing back happens at the same time when it hits the ground. If you can reenact this experiment in your house, you can see that the ball hits the ground and bounces back at the same time. So point C also happens at t1, and the velocity at point C is v2. And know that v2 must be a positive value because the ball is moving upwards. So you need to mark v2 in the upper quadrant and just estimate a shorter length compared to the length of 0 to v1, because as I said, v2 must be lesser than v1. Now point C comes at the intersection of v2 and t1. The last point of interest is point D, and point D happens after t2 seconds. So just estimate a shorter line and mark t2, and at t2 point D has a velocity of 0 meter per seconds. So D comes on the x-axis. That's the completion of first step. We have all the 4 points. Now we need to join them. We will draw a straight line joining A and B that tells us that the velocity increases linearly, and then from B to C we will join them using dashed lines. Why dashed lines? Because it is a change of direction. There is no movement, but it just changes direction. So anyone who sees this graph without knowing the question, they will know that the object changed the direction at t1 seconds. And from C to D, we will again join them using a straight line. The velocity decreased linearly before reaching 0 meter per seconds. And that's it. Our velocity time graph is ready. Before I end this video, I would like to walk you through some aspects of theory regarding the velocity time graph. Now, in a velocity time graph, we can know how the velocity of an object changes with respect to time. We can also derive another two information from the VT graph. The first one is the area under the graph will give us the displacement of the object. What I mean is the area of this triangle will give us the displacement of the ball from A to B, and the area of this triangle will give us the displacement of the ball from C to D. So it's obvious that displacement of AB is longer than displacement of CD. which concurs with our question. Now, another information that we can get is the acceleration. The slope or gradient of these lines will give us the acceleration of the object during the particular motion. Now, an interesting fact here is both the motion, whether when the ball is coming down or when the ball is bouncing upwards, it has a negative slope, which means a negative acceleration. Why negative acceleration? So we need to understand that the ball is experiencing a free fall motion. Free fall motion means falling down under the influence of gravity alone. Since the gravity is pulling the ball towards the ground, the ball will always tend to accelerate downwards, which means the acceleration is always pointing downwards. Acceleration is a vector quantity, and downwards means it is negative value. So that's why we always have negative acceleration for free fall motion. And that's why in both the motion, whether when coming down or when bouncing upwards, the VT graph has a negative slope. That's all for this video, guys. Please refer to the description for links to more YouTube videos on motion graphs. If you like this video, please click the like button, share it with your friends, and subscribe to Uber Schoolie for notifications on new videos. If you have any questions that you would like us to answer, kindly email them to uberschoolie@gmail.com. Till I see you in another video, it's goodbye from Jeffrey. Bye.